All right, great. Okay, so today we are talking working with strings in R. We'll probably won't have time to cover everything today, so we'll continue this on Friday. We'll see how far we get today. Okay. Okay. So just introduction. Basically, learning how to work with strings and text data is becoming more and more relevant, especially as things are moving into kind of natural language processing and stuff like that, text mining, sentiment analysis, all of that kind of stuff, topic modeling. There's a lot of stuff, okay? As far as R goes, there is, you can click this and it will have kind of a whole bunch of packages that are devoted to this, okay? And then there's another site that kind of, fits in with the tidyverse as far as text mining. Okay, we're not going to get into text-based analysis. We're not going to get into full natural language processing in this class, but being able to work with strings and regular expressions is going to be a good tool to have if you ever want to go down this path. Okay, if you want to go down this path, being able to manipulate strings and stuff is great. Okay. Just a bunch of resources if you want to learn more. A couple cheat sheets, all right? I will likely include regular expressions on your midterm exam, okay? And I'll include one of the cheat sheets, okay? Because as you see today, there's going to be a ton of things to remember, and it's too much, right? Especially if you're new, it's way too much. So I'll include one of the cheat sheets, probably this one by Dave Child, and I'll make that clear on the page, okay? And then if you want to just kind of test regular expressions, you can kind of copy and paste a chunk of text here into regexer, and then you can test out your regular expressions and see what what things they match, right? So. Here the pattern is this, and it'll show all of the matches and things like that. So it's very handy to have a tool where you can check the regular expressions that you write. Okay. Similarly, regex 101 has similar features, and these are great. And if you have a text editor, such as Notepad++ or any kind of text editor, a lot of them support the use of regular expressions to kind of search things in text. If you've got a Mac computer, you can use grep and stuff directly from the command line, and I think on Windows and PowerShell you can use, is it find? Something. There's another function. I don't often do the work from the command line. Okay. All right, but let's just talk about some base R character things, okay? And so here I've got this X is a string or character, and I kind of use these things interchangeably. What's character and what's string. So X is hello world, string hello world, and then if we ask R what is it, it's going to say type of character. This is no surprise here. Okay, to create a string, generally you put double quotes, and then if you need to include quotes within the thing, you can use single quotes, or if you want to have double quotes within a thing, you have to escape them using the backslash there. Okay, if you don't, you're going to get some kind of error message, right? Because it thinks this is an error quote, ends the thing, and then it says unexpected symbol here. Okay. When you do character, that's going to create a character vector of a specific length, and then the default value is the empty character. So if you do character 5, you just get quote, 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 5 of these things, okay? The empty character, this quote, quote, is not the same thing as character 0, right? Character 0 is a character vector of length 0, which means there's nothing inside, whereas the quote, quote would be character 1, right? It's a as soon as you have this, now the vector has length 1. All right. We might have seen this. The paste function, that's going to be kind of the most basic and most important, one of the most important functions in base R for dealing with strings, and we use it for like building things together. Basically, you take a vector or several objects. Okay, so it could be one object that's a vector or a bunch of these things. Okay, and it's going to coerce everything into character, and then it's going to paste them together to form one or more strings. Okay, the default argument is a separator is going to be the space character, a single white space character, and then collapse gives you the option of separating the results or not. Okay, so here I've got kind of a few examples. There's also a paste 0 function. Basically is the same as paste, except the separator is not a space. Okay, so you can say paste and separator is quote quote, or you can do paste 0 and basically that's what you have there. Okay, so here are just a whole bunch of examples. Okay, I ate some, and then we use the number pi, and then it says and it was delicious, and basically it pastes these strings. It coerces pi into a string or a character, and then it glues them together and returns one string here. Okay, notice I don't have a leading space here, and I don't have a trailing space here, but because the default separator and paste is a space, it inserts the space there. Okay, here I've got Bears Beats Get Battlestar Galactica, and the separator there is comma space. Okay, and so there we go. We get we have that. Okay. Here I've got one character H and then a vector. Okay, I've got one of these things, and I have the separator is nothing. Okay, and basically it produces. Notice this. It returns a character vector of length 3. Ha, he, and hi. Right. It pastes the H with the A, H with the E, H with the I. Okay, and it produces a vector of length 3. Okay. Here I have vector ABC and the numbers 1, 2, 3, and the separator is nothing. Okay, and so it's going to paste all of these element-wise. It matches the A with the 1, the B with the 2, the C with the 3, so on and so forth. Okay, if you have kind of mismatched lengths, it's going to recycle. It's not going to spit out a warning or anything like that. Okay, and then here I do the same thing, except now I include collapse, and it's comma 0. And so whereas over here it returns a vector of length 3, here it returns a vector of length 1, a single character string where the different elements that it would have returned are collapsed together and separated by the comma space. All right. Does that make sense? What's happening with all of these examples of paste? Okay. Okay. You had to discuss a little bit of print and cat, probably for your first homework assignment. But this is what we've got. Okay. So we've got print and cat, and then there's also format. Okay. So print, normally you put in a character string and it's going to spit it out with character things, but you have a couple options. You got quote equals false, and it will print out hello world without the characters quote marks around it. Okay, you can also use no quote, which is the same thing as print with quote equals false, although I'm used to just using print with the quote option if this is what I wanted to do. Okay. And technically the no quote outputs a no quote class object, okay, which uses the print.noQuote method, and so this result will kind of always print without quotes. Okay, you don't have to constantly repeat yourself by saying quote equals false. Okay, so once you use no quote, in general it will kind of remain a no quote character or class object. Okay. Okay, and then with cat, okay, so X says hello world, and then here I'm going to cat hello world with hello universe, and then the separator is comma space, and it concatenates those two together, and it kind of prints them out. Okay, it looks kind of like no quote, right? Except a key distinction with cat is that it doesn't return an object. So with print, you can actually save the output of print somewhere, whereas cat, if you try to capture its output, like assign, cat x hello world hello universe together, and you try to assign it to something, the value that's going to get assigned is null. Okay, so there's nothing to assign with a cat. The purpose of cat is always to kind of output something onto the screen. Okay, and then the other thing that you'll notice is that print always it returns a vector itself, so you're always going to get the bracket 1, whereas cat's purpose is to kind of output something onto the screen, maybe even a file, and so you're not going to get kind of that square bracket 1, indicating that it's a vector. Okay. Another thing you can do with cat is you can, by default, it outputs to the screen, but you can also specify that you want to output to some file. Okay. And then there's also an option that says you want to append the output to the file, right, rather than just overwrite whatever file currently exists. Okay, and then there's more stuff. You can go into the R documentation and read all about cat, but cat's also a very an important function. Okay, format can be used to kind of make things pretty when we print them. All right. So width will specify kind of the width of the string produced. Trim will trim kind of spacing. Okay. These are the arguments, right? And then justify can kind of move things around within the width, whether it's left or right or center justified, things like that, okay? And then as far as printing numbers goes, you can specify some options here, like how many digits, the minimum number of digits that we should use, and whether it should be in scientific notation or not. So here, we're going to do 1 divided by 1 through 5. So that's going to be 1, 1/2, 1/3, 1/4, and 1/5, right? And if we just if we do specify digits equals 2, it rounds everything off to two decimal places, and then it makes everything a string, right? Here we can set scientific equals true, and it turns everything into scientific notation, right? And then here's the strings character vector with hello world, hello universe, and then we're going to specify all of these things should be width 10, justified left, and we can see it pads it with a bunch of spaces so that each of these strings have a length of 10 characters. Just a few examples here. There's we've got a bunch of functions and base R functions that we can use. So we've got a number of characters to lower to upper, character translate, car th, substring, and string split. Okay, and so I'll just show you a few examples of these things. Okay, number of characters is exactly what you think. Okay, it's going to give you n number of characters. So hello has 5, world has 5, hello has 5, and universe has 8. Okay, to lower turns everything lowercase, to upper turns everything uppercase. Okay, no surprises here. Character translate, okay, takes the string, so y was hello world, hello universe, and basically it says every instance of capital H translate to lowercase y, and so we get yellow world, yellow universe, okay? And then here, this is like leet speak, okay? So the E becomes a 3, and the L becomes a 1, and the I becomes an exclamation point, and the O becomes a 0, and now hello world, hello universe has been turned into this, right? So this is just character translation, okay? So it's kind of like ciphering up a message, like a decoder key or something like that. Yeah, question?
Do you know if spaces count as an additional character?
Yes, spaces count as an additional character, yeah. Okay. Yeah.
So you're going to translate, taking the first argument with each character letter separately, right?
Yeah. It's E goes to 3, L goes to 1.
Is there any way to have it parse like multiple characters?
Not on this function. Okay. Yeah, you can do a whole bunch of like string replace type of things, but character translate is one character to one character. Yeah. I know, like W is like a slash or something, or you can't go from one to many type of thing. Substring will basically take your string it'll take your string and then it'll chop it starting at the second character and ending at the 9th character, or whatever numbers you specify. Okay. String split. Okay, so here okay, x just says hello world, okay? And if I take string split and I say split on the space, it's going to split hello world into hello into one word and then world into another. Okay. Here I'm splitting at O, okay? And so hello world becomes hell and then space W, and then the O gets split and then we get RLD. Okay. All right. All good? All right, now we get to the exciting stuff. Okay, we got stringr, all right? So this this is part of the tidyverse, okay? And you can load it up using library tidyverse or library stringr, all right? And it does a bunch of string functions and stuff like this, okay? Functions and argument names and positions are all consistent. All functions deal with NAs and zero-length characters appropriately, and the output data from each function matches the input data structure of kind of the other functions. Okay, so, oh man, this should be a bulleted list. Okay, I don't know what happened. Okay, so we got string C, which is string concatenation. It's a lot similar to paste. We've got string length, which is pretty much similar to number of characters. Sorry for the formatting here. I'll fix this. Okay. String sub is like substring. Okay. And then there's string duplicate, which will duplicate characters. String trim will trim leading and trailing white space. String pad will pad the string with a white space. Okay. And then string wraps paragraphs. So if you have like a very long string, you can kind of have it wrap to like a certain length. And then string trim will trim strings. Okay, I'll fix that up. And then you got some documentation here. Okay, so here's the regular old paste function. X says hello world. Okay, and so here I'm gonna kind of paste these 4 things together: X, null, character 0, hello universe. Okay, and if I say the separator is comma space, the regular paste function will do hello world and then nothing, comma space nothing, comma space nothing, comma space hello universe. Okay, this might not be what we want. Okay, so string underscore C I think does a better job of handling these things. Okay, and it just kind of skips over these things, right? So the null and the character 0 just gets skipped over and we get hello world, comma space hello universe. So it skips over those. All right, so that's one of the differences between using the tidyverse concatenation function versus kind of the base paste function. Okay. it also, string length is again similar to number of characters, but it also works with factors, okay? So here if I take, so month.name is, January, February, March, so on and so forth. And if you make it a factor, okay, so month name is originally a character thing, and character works fine on it. But if we make it a factor, nchar can't handle factors, okay? So you'd have to do something like, convert everything from the factor to its character thing, anything like that. String length, however, you can plug in the factor right away and it works just fine. So January has 7 characters, February has 8, and January, February, March has 5, and April has 5, and so on and so forth, okay? So that's what we have. And then the other things do stuff as well, and you can read about them. And this brings us to regular expressions, and we'll see how far we get today, and hopefully I can wrap everything up on Friday as well, okay? So regular expressions is, an important thing is to find patterns, okay? And we do pattern matching. And so finding patterns is really useful for all kinds of stuff. And we've got a set of symbols to kind of describe these text patterns, all right? And regular expressions is kind of like a formal language, and pretty much all of the operating systems and different languages support regular expressions. So this is not specific just to R, but you can go over to Python and use regular expressions. You can use it in your your bash command line prompt and use the regular expressions. It's going to be supported in a lot of locations. And truly, if you get a good grasp on regular expressions, you will be, I think, quite valuable to whatever workplace you do, and especially if you're working with text data. And so I think this is something worth investing time into learning. And we have 2 full lectures on the topic because I think it's that important here. Okay. All right. So here's just some applications of it. Right. You can see if a phone number has the correct number of digits and stuff. And so if you're building a web page or something, you can have some way to kind of verify the input that someone has entered. Okay. You can see if you've got a date or an email address, or passwords have certain things, and that's always annoying when a website has weird password requirements. You can check for stuff like how many times the word analysis is preceded by data, computer, statistical, or things like that, right? There's a comic, XKCD, on regular expressions. Is this it? So you have the survival shows, or I don't know, people and I feel like if there was ever a zombie apocalypse, I would just die, right? I don't have skills to build a fire and hunt for forage food and things like that. But if there's something where regular expressions come into play, I might survive here. Okay, and so here's just a silly comic. Where it says, whenever I learn a new skill, I concoct elaborate fantasy scenarios where it lets me save the day. And again, it says we have to search through 200 megabytes of emails looking for something formatted like an address, and that would be really painful to do in real life, right? But then if you know regular expressions, you can swing in, hack away, and then leave, right? And you have saved the day, exactly, right? I don't, these are the fantasies of. Okay, so zombie apocalypse, not so much, but regular expression stuff, maybe we can do it. Okay, all right, and so stringr comes with a bunch of these things. These are a lot like grep. So there's grep. R has some native regular expression handle abilities. But stringr really kind of expands on these things and makes them very useful. So we got string detect, string locate, string extract, string match, string split. Okay, and so detect. I referenced this in Monday's lecture. So if you pair up filter and dplyr, filter with a string detect, you can kind of filter all the rows that match a certain pattern, okay? Because string detect will return true and false, right? And you can use that logical true-false vector to kind of select a certain row or not, okay? But then when you're working with the strings themselves, okay, perhaps extract and match might be a little bit more useful, okay? Locate will give you kind of the position, the character position. Extract will pull out any text that matches the pattern. And then match, we'll learn about capture groups. Maybe today, maybe we ought to wait till Friday. Match will pull out the capture groups, okay, which is a very powerful thing, okay. And then string split if you need to split strings and things like that, okay. And then stringr also comes with a underscore all variation of all of these things. So you can do string detect all, string locate all, string extract all, string match all, okay. And basically it does the same thing, whereas all of these functions I have listed here will just do it to the first thing that it finds. But if the pattern matches multiple times in the string, you'll want to use the underscore all. Okay, otherwise it'll just do the first thing that it finds. Okay, so the simplest regular expression is the literal character thing. Okay, and this is probably what we are accustomed to. Right? You go on Microsoft Word and you do Control F to find, and Microsoft Word does a literal character match. Okay? Maybe you can do like don't match case, and it gets a tiny bit fancy, but basically it searches for character match, right? And so we're probably accustomed to like find and replace, where you go through and you find somebody's, you find all instances of one word and you replace it with instances of another word, right? And so I think we're accustomed to that, and that's a literal character match, and of course regular expressions can handle that. All you have to do is, for the pattern, you just type in the literal characters that you want to match, right? So basically all the letters and digits in the English alphabet, okay? So alphanumeric characters are considered literal, and as regular expressions, they're going to match themselves, right? Okay, so string locate. All right, so let's say the string that we want to deal with, all right, so all of these things come in the form of you have a string and then you have a pattern, okay? So this is the string that we're going to search. I love stats, that's the string, and then the pattern that we want to match is stat, stat, okay? And so string locate will give us back the text position, right? So it gives us the start. It says, I found this match. It starts at the 8th character and ends at the 11th character, okay? But it is case sensitive, so I have I love stats with a capital S, and my pattern is lowercase stat, and it says I didn't find it anywhere. Okay, so simple enough, right? So this is just search and find, right? Here I've got I've made a longer string that says I love statistics, so I am a stats major, right? Which should be in your email signature, okay? And so we've got string locate, and we're going to search for this string stat in this string, okay? And so string locate will only find the first instance, all right? So it says it starts at the 8th character, ends at the 11th, okay? And we can verify 1, 2, 3, 4, 5, 6, 7, 8. Indeed, 8th character ends at the 11th. String locate all will find, if stat matches multiple locations, it's going to return all of them, okay? And so it gives us back a list with a matrix of 2, and it says it found a match at the 8th, ending at the 11th character. It also finds a match starting at the 30th character, ending at the 33rd character, okay? Now you might wonder, like, why do we need the end character, right? Like, obviously stat is 4 characters long, so if you start at the 8th, it's always going to end 8 plus 3 later, right? So well, later on we're going to have patterns where the character match is not necessarily the same length in every single one of these things, right? So stat will always be a 4-character string, But if we put in a wildcard character, it might match 3 characters, it might match 30 characters, and so the start and the end will be useful in those cases. Okay. All right, and so to kind of get into all of these different kinds of patterns that we can build, other than just your literal, like I want to match STAT, okay? We can build out, we can use meta characters, okay? And so regular expressions, really, if you understand how to use these meta characters, you'll be really, really, really powerful, okay? So here's just kind of the list of meta characters that we're going to use, okay? So the dot, or the period, this is the wild meta character, the wild card, okay? And this will match any character, spaces, letters, numbers, symbols, any character except a new line character, right? So it reaches the end of the line and it's going to do this, right? So here I've got a string of 1, 2, 3, 4, okay? I've got 4 things in here, and we're going to do string detect all of these things, search for the pattern N wildcard T, okay? And we're going to ask, does string detect returns trues and falses? Okay, so will it match this? True or false? True. What about this? True. This? True. And true. Okay, we're going to get true everywhere. All right. What about this? NO wildcard. True, 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 false, right? Okay, and that's exactly what we get. True, 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 false. All right, here is this. I've got 5.00, 5100, 5-00, and 5 space 00. All right, and what if I run this? 5.00, what will that return? True, yes or no? True, 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 okay? We won't see the answer just yet, okay? So if you don't want to have the dot be a wildcard, okay, you can escape it, all right? And so any of these meta characters, if you want the literal dot, right, like let's say you actually want to search for the dot, you've got to escape it, okay? So in this case, to escape it, you use a backslash. But in R, the backslash itself is a meta character, so you have to use a double backslash, okay? Which is a little unfortunate. This is kind of unique to R. Like if you go Python and stuff, you're just going to use single backslashes, and it's fine, okay? So here, if I try to search in this string, I've got ABC, square bracket, DEF, and I try to search for the square bracket here, it's going to give me an error, right? So it says, you know, I can't find this, right? But here I escape it, okay? Backslash, backslash, square bracket, and now it is searching for the literal square bracket, and it detects the literal square bracket here, and it says true, okay? So in the same way, with the 5s, if I've got 5.00, it's going to be true, 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 true for all of those things, okay? As we discussed, it matches any character, okay, including spaces and dashes and symbols and other things, okay? Just not new line characters, okay? And again, if we want to match the literal dot, we have to escape it, and so we do backslash, backslash, dot, okay? So 5// dot, 00, backslash, backslash, will match only this one. So that gives us a true, and then the other 4 are other 3 are false, false, and false, okay? So that's trying to match the literal, if you want to match any of these meta characters literally. Okay, what is this? So here we have square brackets. Square brackets define a character set, okay? A character set. So you say like any of these characters, okay? One important thing, and this is something that people have a tough time with, is that a square bracket, a character set, will match only one character, okay? It will match one character if it is but it says match any of these things, right? So here, if I've got square bracket A, E, I, O, U, it will match any one lowercase vowel, okay? So here I've got pan, pen, pin, P0N, P.N, PAUN, and PWN3D. Okay, pwned. All right. So if I run string detect on all of these variants of P something N, okay, what will return true and what will be false? So here we get true, right? PAN, because A is one of these things. PEN, also true. Pin, also true, because I is this thing. This, false, okay? 0 is not one of these characters, so it doesn't match. The dot, false, okay? Inside the character string, this is a literal dot, okay? The dot only takes on the wildcard meaning when it's in the pattern that we are searching, okay? In the character string, this means this is a dot, okay? Here, the dot only takes on the wildcard meaning when it's inside the pattern. PAUN, false, right? The character set matches only one character, okay? So we've got a P, and then the A will work, but then it has to be followed immediately by an N. So the fact that there's a U here is not going to work, okay? And then and this is not going to work because the W is not one of the A, E, I, or U. So we get true, 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 and false for everything else. Is that good? Okay, so the square bracket only matches one character, okay? So if you want to match all capital letters, you can write capital A, B, C, D, E, F, G, H, I, J, K, L, A through Z, right? Okay, now obviously that's going to be inconvenient, all right? So you can define a dash, and it will select a range of characters, okay? And the range of characters is going to be defined by the English alphabet, okay? Which, so here it will say, you can do A through Q, and this will be all lowercase letters from A through Q. A dash capital Q, and it'll be all capital letters from A through Q, okay? If you do A dash Z, lowercase, uppercase, it will match all 52 kind of ASCII, letters and things like that, right? And we got digits 0 through 7 and stuff like that, okay? Yeah, question?
Is there, if you're looking at character text in like another language like French where you have accents, is there any easy way to add the letters with an accent?
Yeah, so I want to say the regular expressions are designed for ASCII text, okay? And then there are variants of regular expressions that allow for non-ASCII text characters. I'm not quite sure, and I'm not quite sure like where in the alphabet A with a accent lies. Okay, I don't know quite know.
It doesn't have a word.
It doesn't, so does it right? It's equivalent to an A when alphabetizing, I think, yeah. But yeah, I don't know, and so yeah, this is very much an ASCII-based, ASCII-centric. I know that's what's the word? I don't know. It's like culturally insensitive, but for computers, right? Like we're only looking at kind of ASCII text, but that's just kind of where we are, right? Okay. So here you can do this, match various occurrences. So what kind of pattern can we write if we want to match 3 consecutive digits? Based on what we've learned so far. Okay. So if I want a digit, I would use square bracket 0-9. Okay, and so that's going to be 1 digit. And then to get 3 of them, I'm going to do that 3 times. So square bracket 0-9, square bracket 0-9, square bracket 0-9. Okay, and so this would be kind of the pattern that I can write to match 3 digits in a row. Okay, and so that will match this 1, 2, 3, and it's not going to match any of this other stuff. Okay, or you can, yeah.
If it was 113, would it not still return true?
Yeah, 113 would match.
So it would.
Yeah. Oh, sorry. Consecutive here is not does not mean like. Oh, I didn't even think about the ambiguity of that statement. Consecutive just meant like 3 digits next to each other, not necessarily like counting up 4, 5, 6 or something like 4, 4, 4, 7, 6, 2, whatever. These would all match. Sorry. Okay. Noted. I'll write that. So I'll say match 3 digits, 3 adjacent digits. I don't know what the right word would be. A group of 3 digits next to each other or something, right? Okay. Okay. Sometimes you don't want certain letters, right? So you can say a negative character set, okay? Basically, same thing. You just put a caret in front of it. You put this little symbol in front. You put it at the beginning, right? You put this character class thing. You got this character set with the square brackets, and then you put the caret in there, and it says, I don't want these vowels, right? So match anything, not any one of the lowercase vowels. So this will match B, C, D, F, G, H, J, K, L, and so on and so forth, right? It'll match basically all characters that are not these 5, okay? So here basically it says don't match anything that's a capital letter A through Z. Okay, so don't match anything that's a capital letter A through Z. So it matches 1, it matches lowercase a, it matches the ampersand, it matches the dash, it matches the caret here. Okay, so again, when it's in the text, they're all literal characters. When it's in the pattern, it's a meta character. Okay, and so here we get true, true, false, true, true, true. Okay. We have to put the caret as the first thing, okay? Otherwise, it's going to think we're trying to match kind of this literal thing here, okay? And so here it's going to say anything that's A through Z or the caret itself. And we get false, false, true, false, false, true here, okay? You might say, well, why don't you escape this? And I'll explain that. Basically, things inside a character set don't have to be escaped, but that's later. Okay, so what if you wanted to say match anything except the caret? So what would I? So square bracket, caret, slash slash, caret, exactly, right? So if we want to say anything but the caret, we're going to use kind of this character class thing using the square bracket, okay? But we say not, and then we want to talk about the literal caret symbol, so we do slash slash caret here, okay? Is this all right? It's like everything's kind of cascading, and it's kind of like, I don't know, like in math class, you're like following along, and then something like somebody kicks your table and you look down and then you look up and then now it's like a whole different world. It can happen with regular expressions. Everything kind of builds up and then like if something along the way gets confusing, it can get hard. So when you're confused, just raise your hand and say slow down, go back, and we can do that. Okay, so again, yeah, if I do this, I'm going to get matches everything except the caret symbol, so we get true, 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 false. Okay. So here's the thing. Okay, when you put a meta character inside a character set, okay, in general, they will assume to be escaped. Okay, so when you put a meta character inside a character set, and this applies only to basically this single square brackets here. Okay, so when you have a single square bracket, this dot here is not a wild card, but it's the literal dot. You don't have to actually escape it. Okay, so I could have actually done this without the backslashes. Okay, but so here's an example. I do the same thing, P and then AE dot IOU. Okay, and then so now this dot represents the literal dot. Okay, so when we say, does this pattern exist here? It's going to be true, true, true here. This is a false, but this is going to be a true, and then these are still falses. Okay, so we get true, 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 false, and then the p dot n is true, and then we get false, false. Okay, so the dot inside is now the literal dot character. The only ones that don't get escaped and still retain meaning, okay, are things like the brackets themselves. Okay, so that kind of makes sense, right? So within square brackets, you get it. If you're going to put in brackets, you've got to escape them. The dash is also important, that it retains its meta-character meaning, because we might want to say the letters A through Z, things like that. And then the caret, if it's at the front by itself, and then the backslash also for those reasons. But in general, all of the other meta-characters, like your $sign and your, I don't know, whatever else, dots, inside character sets, they're escaped. Okay, we have character classes, and these are basically shortcuts to define character sets. Okay, so because a digit is a commonly defined thing, rather than having to write square bracket 0-9 square bracket, okay, you can just do //d. Okay, in other languages it's just /d. Okay. And kind of to help you remember, I think these letters make sense for a lot of these things. So we've got digits, word characters, and space characters, or white space characters. Basically the lowercase is that thing, and then the capital is not that thing, okay? So // little d is the same as 0 through 9. // big D is anything that's not 0 through 9, okay? And then little w is A through Z, 0 through 9, and underscore, and then /w, big W is not those things, and then space is anything that's a space, and then we'll talk about that in a moment. Okay, we'll end here for now, and then we'll continue on Friday here. All right.